Good afternoon and welcome to this SciSales webinar. My name is Jukka Vesa and today the major topic is AX. First, I would like to apologize for a bit of a mishap with the time for the webinar, so we are unfortunately running on 1 hour early. So hopefully all could attend that wanted to attend. So a bit in more detail of today's agenda. First, we will go through a couple of slides about SciSales Smart Antenna, which should be a familiar subject for all of you already. But since it works in conjunction with AX, it's good to freshen up on that. Then a couple of slides about technology trend. So where does the market see AX going and when will AX be a very popular standard? Then about our Wi-Fi 6 or AX portfolio, then the key technical features that it brings with it, and there is quite a few good features. Then we talk about VPA3, the enhanced security for Wi-Fi, and then at the end, as normal, we have a Q&A session. So if you have any questions during the presentation, please just put them in the questions section of GoToWebinar and we will cover them at the end. Okay, so let's start off with Smart Antenna. So Smart Antenna is an adjustable antenna array in our higher end APs. And the goal of Smart Antenna is to, of course, increase capacity, coverage, and especially interference by saving electricity at the same time, because you allocate a certain antenna pattern to all clients connected to that AP. And the very good thing about this method is that it works with just basic parameters, signal strengths, etc. And it works on 2.4, 5 gigs and with all Wi-Fi devices. Okay, so how does a smart antenna work technically? In a conventional world, we have omnidirectional antennas, which are very popular and used in indoor applications in standard APs. And then we have directional antennas, which usually are used in outdoor wireless or wireless links, etc. And smart antenna solution combines both and all of these types of antennas. So it automatically allocates an antenna pattern to each and every device connected to that AP. And also trying to avoid interference, which is symbolized by a microwave in this slide. And it is also able to keep up when the client starts moving. So it is constantly able to adjust that antenna pattern according to that certain client. Okay, and of course, when you have multiple smart antenna APs in the same environment, they are able to adjust not only to the clients, but to each other as well, hence creating a lot less interference to other APs in the same environment. And all in all, a better Wi-Fi result to everybody. Okay, then to the technology trend section. So this is a research done, and basically we are currently at the end of 2019. So AX is officially out and manufacturers are starting to roll out APs and devices and network cards, etc. But the lesson to learn from this slide is that by 2022, they estimate that over 1 billion AX chipsets will be out there. And this is a very important factor since obviously if you are installing AX APs to get the full benefit out of them, you would need an AX network card on your devices. And by only 3 years, they estimate that there will be 1 billion AX devices out there. So AX will become popular in a very short period of time. So now it is the perfect time to set up the infrastructure ready for those AX clients. There is also going to be a naming change for not just the standard, just to be more human readable basically. So AX standard will be also called Wi-Fi 6, and there will also be a symbol in your normal Wi-Fi symbol of your PC or tablet or whatever that symbolizes the standard it is connected to. So for example, when you are viewing from your laptop, you would see a Wi-Fi 6 when it's connected to a Wi-Fi 6 AP. So just to be more clear what standard you are using. Okay, Wi-Fi portfolio-wise, so the models that Sizell is introducing next spring. The first model to come out would be the VAX650S, so our flagship model, and the other ones will follow in the downward order. So the VAX510 and 610 will be next, and the NWA models will be later on during the spring, so May-June time. And the only one with smart antenna technology will be the 650, and it'll be a 4x4 and a 4x4 antenna model with a 5 gigabit Ethernet interface for uplink. And it will also introduce a scanning radio to be able to be more aware of its environment, and a Bluetooth beacon as well. So in a bit more details, so it is a 4x4 with 5 gig uplinks, smart antenna, and it is a Nebula Flex Pro capable AP, so you can install it in our cloud managed portal called Nebula, or standalone, or in an on-premises controller like the NXC or the USG. So basically one AP that fits all solutions. On the screen, you are able to see the dimensions of the AP. And once again, you will see that the AP is made very robustly. It has a lot of hardware features as well, including a grounding socket, a 1 gigabit LAN port, which you can extend the network wired after the AP, and a Kensington lock socket and a console port if you might need it. When we look inside the AP, the hardware is made very robustly and nicely, as Sizell does it usually. And we have a 4 and a 5G filter to minimize interference from cellular networks. Then we have a proper surge and ESD protections there, a heat shield, and the antenna array is totally shielded from the components to improve the signal to noise ratio as good as possible. And each and every component is shielded as well that produces at least a little noise, so we can get the best possible end result for our clients. So it introduces the smart antenna module, which are able to keep up and follow each and every client individually that is connected to this AP. And the PCB has an anti-noise shielding to gain the best possible signal to noise ratio, so they can serve the clients and give a reliable Wi-Fi even when the signal strengths are getting very low. So on the edge of the coverage, you can still have a nicely functioning Wi-Fi. Okay, then to the actual technical features of Wi-Fi 6 and how they work. So this is the stage that the presentation turns into a bit more technical, but hopefully you are able to follow. So the motivation behind Wi-Fi 6 is that in a current Wi-Fi standards that we have up until AC, we have always had issues with high congestion. So when we have a lot of clients in the same area, a lot of clients connected to same AP and a lot of APs seeing each other. So especially we see this issue in hotels, stadiums, airports, shopping malls and schools, etc., where these are affected. And obviously, since it is not just the AP discussing with the clients, but in the current Wi-Fi standards, there are a lot of issues with management frames and waiting times, etc. So the Wi-Fi has to do a lot of things to each and every client that doesn't really involve the data transmissions, but more of a management traffic overhead. Okay, and AX, also known as high efficiency wireless, is designed for these types of scenarios, and it is designed for have less overhead and less congestion, so multiple users can share the same channel at the same time and then talk with the AP at the same time. It also introduces something called spatial reuse, or other known as BSS coloring, which is a native mechanism for high deployment scenarios. So the APs can talk with the clients at the same time, even though they might share the same channel. And all in all, AX APs with A by A antennas, the theoretical throughput goes up to 9.6 gigabits per second. But obviously this is theoretical and in lab conditions. Okay, the major change, or one of the biggest improvements, is OFDMA, and up until AC we have used something called OFDM, so orthogonal frequency division multiplexing, and we are able to talk with one client at the same time. So basically the AP, if we are looking at this slide in here, the AP can talk with one single client at the same time, and it has to wait until the next client is available and free, and there are random back-off times, etc., included in Wi-Fi. So the AP might need to try several times before actually establishing a communication with the client. So the first improvement is a OFDMA, or orthogonal frequency division multiple access. So many of the clients can share the same time slot on that frequency. So up to 30 different devices can actually talk at the AP at the same time. So as we look at the similar chart in here, we can see that on this time section we have 2 clients talking at the same time, 2 clients, 3 clients, etc., and it can be up to 30 clients at the same time, and the AP is automatically able to adjust the required bandwidth for the client requirements, meaning that perhaps the client is just sending a small burst of data, reporting data or something, so it doesn't need that much bandwidth, or somebody is watching YouTube requiring a lot more bandwidth, and it dynamically allocates that bandwidth for each and every client. Also, after this improvement, we also have in the AX, they have increased the amount of sub-carriers to 256. And there are 3 types of actual sub-carriers. There are data sub-carriers, which are used to transmit the actual data. There are pilot sub-carriers, which are used to keep the transmitter and receiver, so the AP and the client, synchronized with each other. And then there are unused or null or guard carriers, which are there to protect against interference. So small quiet times between transmissions, basically. These subcarriers form a resource units. So you can have a minimum of 26 subcarriers in a resource unit or up to the 256 subcarriers. In previous Wi-Fi standards, we had the maximum of 52 subcarriers. So this method is not really totally new. The amount of subcarriers is just grown up to 5 times basically what it has been. So the data can be split into different size of resource units to make it even more efficient to share the bandwidth and the allocated data between clients on that same channel. So we can go in, or the AX standard can go into very much detail when allocating certain amounts of data and resources to each client, hence making it very, very efficient on airtime usage, which has been previously the issue with previous Wi-Fi standards. The next method that we are, or AX is introducing, is download and upload for multiple user, multiple input, multiple output. So a word monster. So previously, MIMO was only implemented on downlink, meaning when the clients are downloading something. So it was basically only halfway one-way traffic that it could utilize multiple antennas at the same time, and multiple users could do it. On AX, it works both ways. So the AP can download and upload data between the clients using multiple antennas at the same time, allocating these to each client depending on the client's needs. So for example, on this slide, we have a laptop with a 2x2 antenna in the network interface card, so it can utilize 2 antennas at the same time, receiving and transmitting. And then we have a tablet and a mobile phone that has only 1x1 antennas, so they are able to use those at the same time as well, making the process once again much more efficient, and the devices don't need to wait that long. So differences between a MIMO and OFDMA is basically that multiple user MIMO is improving the channel utilization and the high rate applications. And OFDMA is splitting these up to very small resource units to allocate the smaller amounts of data to each client and to be very precise on certain applications on what it splits the data for. All right. Then we go to spatial reuse, or BSS coloring, which helps the APs to form a better environmental factor on AP deployment. So if we check the explanation on the left-hand side, and we have APs on channel 1, meaning that each and every AP that are visible to each other, not only do they have to wait until the air between the AP and the client is free, but they need to wait until the other APs are quiet as well before the transmission. So no 2 devices can talk at the same time on the same channel. On AX, there has been introduced a BSS coloring, which gives a color tag for the basic service set. And that again means that APs in a different basic service set are able to talk at the same time, even though they are on the same channel. Meaning that, once again, in the same environment, we can have several different APs that are visible to each other and can hear each other, but due to this method, they are able to serve the clients at the same time, despite that they are on the same channel. So especially on deployments that are designed for capacity, meaning that there are a lot of APs in small areas, once again, schools, auditoriums, hotels, etc. We gain a lot of efficiency by using this method. And smart antenna, of course, helps a lot with this as well. So we can allocate a lot more between the BSS coloring channels, and we can help with the signal to noise ratio, since obviously even though the APs can talk at the same time, they create that noise around them, and smart antenna helps you to reduce that signal to noise ratio to get the better signal to each and every client. Then once again, to improve the airtime efficiency, AX introduces something called a power saving mode, target wake up time. So previously, when stations have tried to communicate with the AP, they are sleeping, then they are sending, and they are just doing this basically on a random periods of time. And if the AP is busy receiving information from station 1, station 2 needs to wait in idle mode and obviously trying to transmit, consuming not only airtime but consuming battery of the device as well. So then station 1 goes to sleep, station 2 starts sending, and station 1 can't send at the same time as station 2. So basically we don't have any scheduling available for clients to communicate with the AP, and since only one client can communicate at the same time with the AP, the other clients need to wait for having that transmission, resulting into poor airtime usage and resulting into unnecessary battery consumption. So target wake up time means that after devices start communicating with the AP, they negotiate the best possible time for that transmission to occur. So station 1, after sleeping, negotiates with the AP that I am sending and receiving at a certain time, and station 2 does the same thing, and then they will not be overlapping, and then they will not have to be idle and try to do retransmissions. So obviously, if you schedule your meetings of the day, it is much more efficient than call each and every customer at the same time and try to figure out which one would be available for meeting at this hour. Okay, other features that AX introduces are a longer symbol duration, meaning that the signal can travel longer distances before dying out. A longer guard interval, which is basically needed for the previous. So we have longer spaces between transmissions, so we are able to avoid interference and have that longer symbol duration as well. We also have an improvement in modulation technology to 1024 QAM, meaning that we can push more throughput through the Wi-Fi. Obviously, since we are putting a bigger QAM, we are making it more risky to high signal to noise ratios. So if you have a crowded environment, the AP will most likely downgrade to 256 QAM to have that connection available and have the connection quality rather than the speed. But in low signal to noise ratio environments, you obviously have the speed gains as well. So just as an illustration, AX versus AC. So in these charts, we see megabits per second and how many clients are connected in the AP. So as we see, and as we talked about earlier, the results of these new technologies, AX keeps the steady performance even though a lot more clients are connected. And AC, due to the fact that the amount of management frames and random backoff times, etc., grow and grow and grow and grow and grow, the performance of the AP degrades, the overall performance of the AP degrades while more clients are connected to that AP. Then per client throughput. So obviously, since many clients share the same throughput, it will go down even if you have an AX or AC, because the shared bandwidth stays the same. But you can clearly see the difference that more clients you have on the AP, AC clients will drop a lot more. So the blue line here represents the percentual difference between AX and AC on per client throughput when the client amount grows. So especially when you have a lot of clients, AC is far more better on handling them. When you install multiple APs in the same environment, the results are even better. So when the client has multiple APs available for them, so aggregated throughput, so all clients together on 2 APs, and once again up to 100 clients, AX keeps steadily performing and AC keeps dropping due to the fact that the management traffic or the background traffic keeps growing while the amount of clients keeps growing. Same thing on per client. So obviously the per client throughput will drop when you get more and more clients into the APs, but AX keeps performing way better than AC, even on per client throughput. Then we move to VPA3. So on the encryption key basis. So motivations behind VPA3. Currently, if we have an open Wi-Fi or 802.11i, so without any passwords, all data is being transmitted on plain text, meaning that if you are doing a packet capture on an open Wi-Fi, you are able to find out HTTP passwords, etc., which obviously is a security risk. VPA2 personal, the encryption keys can be cracked by brute force. Obviously, this needs an access to that network, packet capturing, and going from there. Then VPA2 Enterprise is still very secure, but can be improved. VPA2 Enterprise is not only used in banking, governments, or military, like the slide gives you the impression, but in bigger companies, you usually refer to an AD server or something and use VPA2 Enterprise encryption. So in VPA3, we introduced something called Enhanced Open, which encrypts the Wi-Fi packets even on the open Wi-Fi using SSL protection. VPA3 personal is harder to crack because of the new handshake process or simultaneous authentication of equals. VPA3 Enterprise only introduces a stronger encryption, and obviously since we are talking about encrypted Wi-Fi, .11w is mandatory, so protected management frames need to be there for these functions to work. Okay, so first let's discuss in more detail what is Enhanced Open and how it actually works. So in Enhanced Open, APN Station negotiates a master key in association stage, where each device generates a number of exchanges to each other. The master key is based on these two numbers. The full process is called OWA, the OWE, or opportunistic wireless encryption. And after the master key has been established, both devices use something called a four-way handshake to exchange other information and generate the encryption keys. So this is basically the difference in enhanced open and the current open that we have. So in the current the open Wi-Fi, we have an authentication and association, everything done in plain text basically. And in the enhanced open, we have the authentication, then we have the association and the master key generation, and then the encryption key generation after that. And the transmissions will be done encrypted. So there is no possibility of eavesdropping. So even on open Wi-Fi can be secure. Okay, then to VPA3 personal. So VPA2 personal is insecure because of the way it generates keys. So the master key can be cracked by using brute force. In the four-way handshake, most of the key information is sent in plain text and is public, so for everybody that can join the Wi-Fi can see this. So hackers can capture those wireless packets and brute force to crack the password basically, and then obviously go from there. All right, so VPA2 personal includes a password and an SSID, which it generates a master key from, and included with key materials, it equals the encryption key. Okay. So a summary, the key materials are in plain text and can be cracked. Okay, VPA3 personal, the master key is harder to be cracked because it creates the password plus key parameters from the station and the AP to generate the master key. And this is also known as dragonfly handshake. All right, so there is less chance of the key material to be leaked. In VPA2 personal, the AP checks the station's password in a four-way handshake, which means that no matter the password right or wrong, the AP and station will still broadcast the AP nonce and the station nonce, which will become a security vulnerability. Therefore, VPA3 personal adds two steps to verify the password directly in authentication process. So the afterwards handshake won't happen if the password is wrong. So there is less chance of the material being leaked because of this process before the association. Okay, so VPA3 Enterprise is backwards compatible with VPA2 stations, and it basically only increments a better encryption for the Wi-Fi. Otherwise, the process is more or less the same. Then, since VPA2 and 3 are not compatible with each other, so as standard VPA2 clients could not support VPA3 encryption, it's demanded by the Wi-Fi Alliance that we introduce something called a transition mode. And how that actually works is underneath in the AP broadcast to SSIDs with both of these encryptions. So in an enhanced open, it just on the background creates an open SSID, and with VPA3 personal, it creates a VPA2 SSID. So in the transition mode, where a VPA2 client connects to the AP, it receives the beacon for the first SSID with the information including that this has a transition mode, and a VPA2 or an open SSID is available also on this AP. So the client will automatically connect to that AP if it's unable to support the VPA3 or the enhanced open encryption. So basically the client will not see any difference. It will just automatically connect to the supported SSID. So obviously, since two SSIDs can't share the same name, there will be a 10-byte suffix added to the SSID name. So even though the visible SSID name is Zyxel Wi-Fi, on the background there is created an OWTM Zyxel Wi-Fi XXXXX SSID, which the clients connect to. Okay. So this is the method of having to basically the only one visible SSID, but VPA3 and 2 clients can work with that same visible SSID. All right. Then I have talked through what I was planning to talk through. So then it is time for questions and answers. So far, we only have one question. Will we send the recording after the session? We won't send the recording, but the recording is visible through our partner portal, so you can view it from there. Will there be a software upgrade to allow VPA2 devices to run also VPA3, or is new hardware the only option? As far as we are aware, new hardware is the only option because VPA3 is also a requirement from the chipset. So it is not just our software, it's from the chipset vendors as well. How about controllers and firewalls? Controllers and firewalls, since the AX is a Wi-Fi radio standards, all controllers and firewalls will support AX APs with software updates, including Nebula. I will keep the webinar running for a couple of minutes to wait more questions. But if you don't have any, I would really like to thank you for joining this afternoon, and hopefully this was informational, and have a great afternoon. Is the mesh function integrated? Yes, integrated, and integrated doesn't really have to do with AX standard at all, but the AX APs will start supporting mesh as well. Merry Christmas and Happy New Year to all of you. Seems that there are no more questions regarding this subject, but if you happen to think of any afterward, just please drop me an email and we will take them from there to jukka@zaisia.fi. Thank you all once again and goodbye.